Today's demonstration of RoboArm Remote. Students will be instructing a RoboArm located in the state of Nebraska. Two robotic operators are located in the state of Georgia. 1,265 miles separate the lab and the school. You will watch the students issue RoboArm commands and then see as the distant RoboArm responds. Let me introduce you to the participants in today's demo of RoboArm Remote. First, Dan Walsh, the designer of RoboArm Remote software, is coming to you from the lab with the RoboArms in Spalding, Nebraska. Thank you, Dan. Second, the student operators are 6th grader Brantley Henson and 8th grader Edward Lopez. Both attend Huntington Middle School in Warner Robins, Georgia. Thank you, boys. Next is Mr. Rodney Johnson, technology and engineering teacher at Huntington Middle School. Mr. Johnson teaches Edward and Brantley, and he is there with them in his classroom. Thank you for all your help, Mr. Johnson. I would like to acknowledge Dr. Marlon Robinson, principal of Huntington Middle School. I'm Leah Melcher, president of Goldenrod, serving today as your MC and facilitator from Tampa, Florida. And now to introduce the star of the show, RoboArm. To reduce visual distraction, we're going to remove our picture windows so that only RoboArm will remain. You will still be able to hear me narrating and the boys interacting with me and each other. Dan is shutting off the pictures. Okay. Operators, go to the main menu and select Manual Mode 1.
Do you want me to share my screen?
Brantley, yes. Please share your screen and leave it on until we tell you to turn it off. Be a long time. For your information, conference attendees, RoboArm has 5 axes which correspond to the human arm. Axis 1 corresponds to the torso, which twists right and left. Axis 2 is the shoulder, which rotates up and down. Axis 3, the elbow, goes up and down. Axis 4, the wrist, rotates right and left. Axis 5, the hand, opens and closes. In mode 1, the simplest mode of operation, pressing on the mouse simply moves the selected axes until it's released, similarly to using a joystick. While it might be hard for you to see on the software screen, the columns of 5 boxes each are to control the 5 axes. Axis 1 is the row at the top, and axis 5 is the row at the bottom. The left, dark green side moves left, down, and closed, depending on the axis, and the light green side moves up the corresponding axis, right, moves the corresponding axis right, up, and open. Okay. Brantley, I'd like you to move axis 1 to the left and show us an obtuse angle.
Okay, it's there.
Now move axis 2 up and make an acute angle. Do your counting. Hey, please move axis 3 down and make an acute angle. Okay, now I'd like you to rotate axis 4 to the right so that the hands that are attached to it are perpendicular to the table. You can tell him when he's gotten there, Edward.
It doesn't want me.
Are you ready?
He's working on it now.
Okay.
That's good. That's good, he said.
Okay, thank you. Now, axis 5, please open the hands.
So Brent just clicked axis 5 and I see the hand moving wide open. Wow.
Okay, now we're going to advance to mode 2.
Mode 2.
Okay, Brantley and Edward have selected mode 2. Mode 2 requires the operator to specify the movements of each axis in degrees. See the box on the screen, the gray box? That is where they will enter the number of degrees to move each axis. Boys, your task is to return RoboArm to the home position by moving each of the 5 axes, which you moved in mode 1, back to the starting position. Before you start, I'm going to ask you a question, Edward. Edward, what can you tell me about the home position?
To go back to his original position.
Right. Do you think that home position has anything to do with 0 on the number line?
Yes. Because 0 is the starting point.
Exactly. On graphs, what do we call the home position? Where the X and Y axis cross?
The point of origin.
Exactly. Okay, I'd like to ask you then, why is the home position important?
It's where we start and end at.
Right. To measure anything, we need 2 things. What do we need in order to measure accurately anything? Degrees or inches or anything.
It's the
Need a starting point. I've already said a starting point. What else do we need?
the ending point.
Exactly. Okay. And in when we're working with RoboArm is our starting position for deciding how many degrees RoboArm should move. And our ending position will be wherever we decide to move it to. Since we have 5 axes, we must define a starting or 0 point for each axis. Goldenrod has arbitrarily defined the home position for RoboArm. I'm going to ask Brantley to describe the home position for RoboArm.
The home position for RoboArm is like the place where it starts and should end.
Right. What is that for axis 1? How would axis 1 be lined up?
Axis 1 would be lined up with that green line.
Between point A and C in
Yeah,
the front? Okay. And what about axis 2?
axis 2 should be perpendicular to the table.
Right, right. And axis 3?
Axis 3 should be parallel with the table.
Good. And axis 4, the wrist.
The
How would
wrist should be parallel to the table too.
Okay. And how about the hands?
Should be closed.
Exactly. All right, guys, you can return RoboArm to the home position.
Okay.
Try to try to put
Using mode 2, you're going to return RoboArm to the home position. Okay, I see axis 2 going. That looks pretty good.
Good job, Brantley.
Did you go
So
far
Brantley,
enough on axis 1?
No, not yet.
Okay.
Is that correct?
That looks pretty good to me.
High five, Brantley. Good job.
Now, I saw that you moved 110 on axis 1, and then you moved it another 5. Can you boys tell me why you picked 115? Or why you picked 110 to start with?
Because at the line it's 95 degrees, and we went what looked like an extra 5 degrees, so that's why I went for 110 at first, but then I saw it was too short, and so I
Okay.
went far.
Okay. Very good. Very, very good.
Sort of
Um,
like debugging it.
Yes, Mr. Johnson?
I said, sound kind of like it's debugging it a little bit. You figure it out, you go back in to fix it, and until you get it precise. Using the
Exactly.
axes.
Mhm. And he used good reasoning for estimating. It was greater than 90 degrees, and it looked maybe 20 degrees greater than 90. So he said 110. It turned out it was 115. So a 1 degree is really very hard to see. It's 1 minute on a clock this size or any size would be 6 degrees. So you can see how difficult it is to even see 5 degrees. It's less than 1 minute, an angle the size of 1 minute on that clock. I want to ask you a question, Brantley. Why didn't you, when you were returning it to the home position, why didn't you start with axis 1?
Because so I could get a better, so I could see axis 2 and 3 better, get the more precise, then return it to the home position and get axis 4 and 5 right.
Very good. So it was so that you could see them on sideways. Now for the
Yeah.
best part. Please go to mode 3. Mode 3 is called the teach pendant mode. It starts off, the software starts off looking like mode 1 as we move RoboArm by sight without specifying degrees, just like we did in mode 1. However, in mode 3, RoboArm is being taught and it's remembering each instruction given to it in sequence. Once we're finished teaching RoboArm the sequence of commands required to complete the task, RoboArm will go home on his own and then display the commands in the box on the screen. They will be displayed in code. The code is called RPL for RoboArm programming language. After loading their commands to RoboArm, RoboArm will execute the routine he's been told or taught. Attendees, you will watch it execute. As you do, look for places in the routine where you think the code might be changed to improve the execution. You can look at, later, Brantley and Edward will debug the program. You can look at the code and see if there are places where you can see a pattern in the numbers you couldn't see in the movement. You can look at the movement and see if you see a pattern in the movement you don't recognize in the numbers. After they're finished, they will debug their program. See if your edits, if the edits you would have made, are the same ones that they did. Okay. All right, guys, here's the problem. A cylinder of poisonous liquid has been unloaded at the wrong location. It has been unloaded at point A, and it should have been placed at point C. To correct, the company has called in its 2 expert RoboArm programmers, Edward and Brantley. This is your task. Using RoboArm, please pick up the cylinder and place it where it needs to be. There is no lid on the cylinder, so be very careful not to spill any of the dangerous liquid, or the plant may have to be evacuated. Brantley, turn the teach pendant on, and you and Edward solve this problem.
Each finger on and
Do you think you could do it correctly?
yeah.
Okay.
Don't waste it. So which particular one you're fixing now, Brantley?
3,
Axis elbow 3. Now you're doing which one?
2,
Axis 2, which is that.
And what he's done by doing 3 up first and 2 down second is to extend the radius, so he's out closer to the edge of the circle by gaining extension. 3 up and 2 down.
Now you're doing axis 2, which is lifting it up. Doing a pretty good job, Edward?
Yeah.
Say good job.
Great job.
Oh, that looks a little too far. Oh, back again.
Ooh. Close. Oh, wow. Okay, you didn't drop it or spill it.
Good job.
Thanks.
So you made RoboArm go back to its home axis, Brantley?
Mm-hmm.
Now be sure to wait until it has returned home and the motors stop moving before you do anything. Read the messages on the screen. And okay, there's the command window, and it's filled up with the commands that Brantley told RoboArm, and he remembered. Now, Brantley, can you read, maybe the first 4 lines and tell us the punctuation and everything, and then we'll go back and translate it.
5, comma, O,
And what's that mean?
5 open,
Good.
1, comma, L, comma, 44, 1 left, 44 degrees, 3, comma, U, comma, 23, 3 up, 23 degrees, 2, comma, D, comma, 34, 2 down, 34.
Okay, and then the next one is 5, you close the hand. Okay.
Yeah.
Now we're going to, Brantley, I'd like you to debug the program, and he is going to debug it using a debugging technique called a structured walkthrough. And Brantley, I'll tell you what kind of errors to look for first, and you find them and correct them. And it's good to say out loud what you're doing. Try not to get ahead of me. Okay, let's go up to the beginning. Please go up to the top of the program. Okay,
He's up it.
he's up there. And the axis 5, that's good. Left 44. Well, we knew it was a 45-degree angle, so 44 has got to be real close. 3 up, 2 down, 5 closed. I'd like you to look and see if you see any commands. I don't see any yet. See any commands that are redundant, where the same axis has commands in a row. More than one command by the same axis.
So something that really stuck out to me was 1 right 90 and 1 left 8. I
Okay,
think that should 1 right 82.
exactly. So you're combining those 2 commands. Why did you subtract them?
Because left, if you're going right and then left, so you have to subtract it to get to 1 right 82.
Exactly. On the number line, you were going to the right and then you turned around and went the other way. So you went backwards. 8 steps backwards. There we go. Okay, what's your next one?
And do you think I need to change 2 up 7 and 2 down 7?
Why don't we, you went up 7, then you went right, then you went down 7. You know, why don't we wait and watch it execute and we'll know for sure. Then you went right 9. So you went back again, right 9. 5 open, 2 up, keep going down, and 5 closed. Now let's execute this program and let's watch it when it gets down there past the 5 closed, and we'll see. Load it to RoboArm and execute.
You just executed it. Let's see what happens. We debugged it right or
That
not.
looks real good.
It's looking good, right?
It was close, but hey, it worked. I thought it was gonna tilt over, but it didn't. So I guess you're an expert coder.
And now RoboArm is going home. That H command at the bottom is a home command. And the RoboArm puts that in when you turn the teach pendant off, because it says, okay, I learned my lesson.
It's pretty cool.
2 up 7, and then you went down 7 again. So you closed the hand, then you took 2 up, then you moved to the right, then you went 2 down, and then you went right. I believe that you could put the commands together, 2 up 7 and 2 down 7, 5 closed. No, you've got to get up out of the way. You've got to get up out of the way. So no, you can't. But you went right 82 and then right 9. I think you can combine those two. Okay, right 9 with right 82.
So he's changing the code now and see what's gonna happen in regards.
Right, now you're back to 91. And you know, that made better sense to me since you went 45 and now you had to go back 45 and 45. That makes better sense to me mathematically, but we need to watch it in real life and see. 2 up 7, 1 right, 2 down, 5 open. Okay. Yes?
Can someone move the tube, please?
Oh, the tube. Dan, can you move the tube for Brantley?
In what position, Brantley, is he moving it to the what?
A.
To A position?
Yeah.
Mhm.
Thank you, Dan.
You're gonna repeat the code, hopefully that it
So
will be
now
more
load your
accurate.
program to RoboArm.
He just hit load program.
Okay, and wait for it to respond. And it said 12 commands loaded. Okay.
He just hit execute. Let's see.
It's looking good.
Oh, very good.
That code seems to work better than the first. It's more accurate and just more precise.
It is.
So with practice, you get perfection.
Very good. I noticed a pattern. I'm going to ask you about this, Brantley. I see a pattern in the numbers. The first time you moved axis 1, you moved it, I believe, let me see if I can see that, 44 degrees. Wasn't that true?
Mhm.
Okay, and then when you moved it back at the end, you moved it 92 degrees.
Mhm.
You would think you would have moved it 45 and back 90. But like we talked about, an angle that small, that few of degrees, that tiny of an angle is almost impossible to see with your eyes. But when you look at the patterns in the number, what do you think might have been exactly the right numbers?
Exactly the right numbers?
Instead of 44 and 92,
Maybe 45 and 90?
that's what I'm guessing. But this is good enough. And Brantley's goal, I wanted to hope you noticed that it loaded 12 programs, 12 commands were loaded okay. Brantley's goal was to get the program down to 12 lines or 12 commands because 12 is the most efficient way that this program could have been written to affect that movement from A to C. If he would put in a line 13 for a pause command, he could pause the execution at the home position, and so that you would see it rest there. As you, Brantley, I'm going to have you do something new. I'd like you to take out the commands with your the RoboArms at the home position. Just delete the commands in the box, so the box is empty.
Okay.
Post deleted.
Okay. Now, please turn the teach pendant is off. Okay. Turn the teach pendant on, and then turn it off again. Just really quick, on and then off. Very good. Okay. Now we know there's no commands in the box. Whoops, there's a home command. You can delete that. Okay. Would you write you can to the attendees, after you've mastered the teach pendant, it is possible to go into that command window and write the code yourself without moving the robot first. First, you write the code and then the robot executes, and to see how good of a programmer you've become. So would you write we're just going to do something not very important, like put in axis 1 to the left 30 degrees. So you type in 1 comma, yeah, you got it. L comma 30. Okay, and in line 2, would you move okay, you've got it now. Would you next time left first instead of the number? The syntax for this language is axis, direction, number of degrees. But Brantley's going to make an error, and when you're typing in yourself, you can make errors. So would you put in 1 up 90? Okay, try to load that program to RoboArm. And it says, error, it is missing the end of command separator at line 1. Well, you didn't put in the semicolon at the end. Okay, so put in the semicolon and try it again. Now load the program. It says another error, illegal command encountered at line 1. An illegal command would correspond to a grammar mistake. He has axis 1 going up, and axis 1 doesn't go up and down, it only goes right and left. There are no unidentified errors when programming RoboArm. All the mistakes that you can possibly make come with an error message, so you know the line number the error happened in and the nature of the error. It makes debugging a lot easier. We're almost to the end of our presentation. This was a very simple problem today that Brantley and Edward solved using the teach pendant. But as they become better at their math skills and more capable with moving a RoboArm, the problems can become more and more difficult. Now their motor skills won't be called into question. It will be their math skills and their problem-solving skills. For example, instead of having something at point A that needed to move to point C, we could have something at point A and point C, and they're in the wrong locations. A needs to be at C, C needs to be at A. In order to do that, it's really not a hard problem. You'd pick up the thing at A and move it somewhere else. Pick up the thing at C and put it at A, and then go get the thing from A and put it at C. So logically, it's not a very hard problem to solve, but it can become more complex if you're not allowed to just make a straight arc from A to C. What if there are places in this factory floor that are hot, and if the material passes through that column of hot air, it'll be ruined. So then you have to plot your route from A to C without passing through those areas. Sometimes the cylinder of hot air could be 10 feet tall. Sometimes it could only be 6 inches tall. If it's 6 inches tall, you can pick it up and go over the top. If it's 10 feet tall, you're going to have to plot a route around it. Well, this is the end of our presentation today. Thank you so much, Brantley and Edward, Mr. Johnson and Dan. And we'll end the meeting and say goodbye. Bye.
Thank you.
Bye.
Bye.
Bye, boys. Bye, Mr. Johnson.
Bye.
Bye.